Okay, getting into Chapter 13, Section 2, we're going to be talking a little bit more about factoring, just like we did in Section 1, but we are going to talk specifically now about special type of products. For example, we're going to go over how to do the sum and difference of perfect squares and the sum and difference of perfect cubes. So the first thing I want to talk about is how to identify a binomial as the difference of two perfect squares. So verify that the expression is a binomial, and binomial means that it should have two terms. Then verify that the absolute value of each term is a perfect square. So if you look at the first and the second term, you want to make sure that they both, if I put them into the square root function, I would get a whole number. No decimals for these type of problems when you're trying to factor. Verify then that the second term is subtracted from the first term, so there always needs to be a minus sign in between the two terms. So our pattern should look something like this, a squared minus b squared. So if you can square root the a and the b term, and if there's a minus sign in the middle, then you should be able to write this as a factored form of this difference of two perfect squares. So what we're going to start with is just some examples where all we do is identify if they are the special product, so if they are the difference of two perfect squares. So I'm just looking for a yes or no answer here. So if I look at x squared minus 9, if I try to square root x and I try to square root 9, I should get x and 3, and then there is a minus sign in the middle, so this one should be a yes. For the second one, I can square root a squared and the 49, I would get a and 7, but there's a plus sign in the middle, which means that it's not a difference, because difference would be subtraction. So that one would be a no. And for this one, m squared minus 27, I can square root m, but I cannot square root 27. That doesn't come out to be a nice number if I plug that in, so that one's also a no. For 3y squared minus 25, again, I can square root the 25, but I can't square root 3, so that kind of causes a problem here. I can square root y squared, but just not the 3, so that one's also a no. For number 5, we have 9x squared minus 4. If I square root 9x squared, that would be 3x, and square root 4 would be 2, and there is a minus sign in the middle, so that one's a yes. And the last one here, I have 4x squared minus 4x plus 1. Right away, hopefully you guys see that this looks different than all the other ones I've shown you, because there are 3 terms, so this is not a binomial, because there's 3 terms, so this would be a no. If you're trying to factor the difference of two perfect squares, these are the steps that you want to follow. Take the square root of the first term, take the square root of the second term, and write one factor as the sum of those two items, and then write the other factor as the difference of those two items. So for example, if you had that a squared minus b squared, you would square root each term, and so each set of parentheses gets the square root term, so you put whatever the square root of a squared would be, so you see that a distributed out and the b, and one of them gets a plus sign, one of them gets a minus sign. So this is the pattern that they will always follow, so this is kind of a shortcut that we can use to factor these. So let's look at some examples. A squared minus 9, again if I square root the first and the last term, then I would get a and 3, so that factors to a plus 3 and a minus 3. For x squared minus 36, I can factor that out to say x plus 6, x minus 6. 4x squared minus 1, so now that I have a number in front of that x squared, make sure that it's still a perfect square number, so this would be 2x, and then the square root of 1 is just 1, so we would have 2x plus 1, 2x minus 1. Now this one is just written backwards from all the others. You've got the negative 49 first, plus 16m squared. If you need to rewrite it so that it says 16m squared minus 49, I would go ahead and do that, especially when you're trying to factor it. We usually want the letter to be on the first term. So the square root of 16m squared would be 4m, and then the square root of 49 would be 7. So we have 4m plus 7 and 4m minus 7. In order to identify a perfect square trinomial, so we're moving away now from the difference of two perfect squares, we want to verify that the expression is a trinomial. Trinomial would mean that there are 3 terms. Verify that the first and the last terms are positive and perfect squares. So the first term and the very last term, they both have to be positive, so you can't have negatives, And again, they both need to be able to be plugged into that square root function and get a whole number, no decimals. Then what you're going to do is take the square root of the first and the last terms, you're going to multiply them together, and then you're going to double it. And that should match the middle term. And it doesn't really matter if the middle term is positive or negative, because again, if you have two negatives or two positives multiplying together, you're always going to end up with a positive. So that middle sign does not affect the problem at all. If it doesn't double the middle, then that means that this is not a perfect square trinomial and it's not able to be factored. So the pattern would look like this. You could have two options. You could have a squared plus 2ab plus b squared, or a squared minus 2ab plus b squared. That's what I was talking about. You see how one says plus 2ab and the other one says minus 2ab. When I mentioned earlier that it doesn't matter what the sign is of the middle, just as long as it doubles the a and the b term together. So again, we're first just going to start by verifying that trinomials are perfect square trinomials, so I'm looking for a yes or no answer. So I have x squared plus 14x plus 49. So I would check square root the x squared and the 49. That would be x and 7. So I'm taking 7 times x, and then I double that. So 7 doubled would be 14x. So it does match that middle term, so this one would be a yes. For this one, I square root that 4m squared, I get 2m, and I square root 9, I get 3. So I'm thinking 2m times 3 would be 6m. If I double that, I get 12m, so it does match that middle term, so this is also a yes. For this last one, the square root of 9x squared would be 3x, and then the square root of 16y squared would be 4y. So 3x times 4y would be 12xy. Double that, double the 12, you get 24xy. So again, this is a yes. Now we're going to explain why these ones are not perfect square trinomials. So I'm looking for what's causing the problem here. For this one, that last term, -1, is negative, and that term has to be positive. Remember, the first and the last terms both need to be positive. For the second one, 4x squared plus 6x plus 9, if that middle term is 6x, that is not twice the product of 2x and 3. Again, square rooting the first and the last term, that is already 6x, so it didn't double the middle, because the middle term should be 12x. X squared minus 5x plus 4, again, that middle term, -5, is not twice the product of x and 2. Twice that should actually be 4x. For this one, -4x squared minus 4x plus 1, I see that negative in front of that -4x squared, that first term. So because that's negative, that means it's a no. That term, remember, has to be positive. In order to factor a perfect square trinomial, you want to write the square root of the first term, write the sign of the middle term, and write the square root of the last term. So you just have to square root the first and the last terms, very similar to what we were doing at the start of this video. And then that sign in the middle, so whether it's plus or minus, that's what goes in between your two terms. Indicate then that it's the square, so we put that whole quantity in parentheses and we put a little 2 exponent next to it. So symbolically it would look like this. If I have a squared plus 2ab plus b squared, that would be a plus b squared. And then a squared minus 2ab plus b squared would be a minus b squared. So let's look at some examples. So some of these are the ones that I went over earlier where you guys were saying yes or no. So for this one, I would do x plus that 7, square rooting the first and the last term. That plus sign in front of the 14x tells you that you put a plus sign in between x and 7. That whole quantity gets squared. 4m squared minus 12n plus 9, square root 4m squared, that would be 2m, square root 9, that would be 3. Put a minus sign in the middle of them. And then for this one, the square root of 9x squared would be 3x. The square root of 16y squared would be 4y. So we have 3x, 4y, plus sign in the middle because 24 has a plus sign in front of it. Okay, now we're going to end this with the sum or difference of two perfect cubes. So in order to identify it, you want to make sure again that your expression is a binomial, so it needs to have two terms. Verify that each term is a perfect cube so that you can cube root each of them and get a whole number. So your pattern is going to be a to the third plus b to the third, or a to the third minus b to the third. So again, we're going to practice just identifying them, so we're going to write yes or no for these problems. So a to the third minus 27, I can cube root any variable like a to the third, it would just be a, and then the cube root of 27 is 3, so this would be a yes. The cube root of 8 is 2, so that first term would become 2x, but I can't cube root 9. I would get a weird number if I tried to do that, so that one's a no. For this one, the cube root of 8y to the third would be 2y, and then the cube root of 125 would be 5, so this is a yes. For this next one, I can cube root a to the third, but I cannot cube root 16b to the third, so that one's a no. I can cube root both of these terms. I would get 3x and I would get 2, so that one's a yes. And our last one here, again, very similar to when we were doing our perfect square binomials, or the difference of two squares. This one here has 3 terms, so it's a trinomial, which is an automatic no. In order to factor the sum of two perfect cubes, write the binomial factor as the sum of the cube root of the two terms. So like I was explaining before, cube root the first and the last terms. And then we'll write them out as this whole expression. It kind of makes more sense for me just to show you guys the rules here. So if you have a to the third plus b to the third, you just need to cube root the a and the b term. And you just fill them in where you see a and b here in that expression written out. For the first one, you'll have a plus b, and then it says a squared minus a times b plus b squared. So you will have to do a little bit of simplifying after you've found your terms a and b. The same rules apply for the difference, so cube root both of them, and then you'll follow the same rules. So this one looks very similar to that last rule I just showed you. The only difference now is we've got some different signs. So we have a minus b instead of a plus b, and then that first plus sign on the last rule was a minus sign in front of that AB term. So let me show you some examples here where we actually factor. So I have 27a to the third minus 8. So if I cube root the first term, that would give me 3a. And if I cube root 8, that would be 2. So like my a term for my rule would be 3a, and my b term would be 2. So this factors to 3a minus 2. And then I square my a term, so that's why they have 9a squared, plus the 6a, because that would be the 3a times 2. And then the 2 squared would be 4. This one is the sum of two perfect cubes. So I have this cube root of m to the third would be m, and then the cube root of 125n to the third would be 5n. So writing this one out would be m plus 5n, and then m squared minus 5mn plus 25n squared. Again, m squared is that first term. The middle term there is the two cubed roots together, so 5n and that m multiplied would be 5mn. I'm just putting those letters in alphabetical order, and then squaring that second term, 5n, is how I get 25n squared. For the homework, make sure you guys go to the homework website and use the Google Doc that I have created to do your homework problems on it. Make sure that you submit your assignment to me in my email. And again, if you have any questions, please make sure that you're emailing or reaching out so that I can help you.